frequency modulation. In amplitude modulation, the amplitude of the carrier was modulated, and in the frequency modulated, the frequency of the carrier is changed by the modulating signal. Let us take the carrier signal is Vc equals to Vc cos omega ct, and the modulating signal is Vm cos omega mt. Then the instantaneous angular frequency of the frequency modulated carrier will be changed as such by taking a proportional constants kf and multiplying it with the modulating signal. We get the changed frequency of the carrier, and then the instantaneous angular displacement will be the time integration of that angular frequency, and this is ultimately omega c into t plus kf into vm by omega m sine omega mt. So the instantaneous phase angle theta t suffers a maximum deviation of this term, taking sine omega mt equals to 1, maximum help. So the frequency modulated wave is simply written as Vc cos theta t, that is Vc cos omega c into t plus kf Vm by omega m sine omega mt. The instantaneous frequency f of t of the frequency modulated carrier is simply given by omega of t by 2 pi. If we write this as 2 pi fc plus k vm cos omega mt, then it will be fc plus k vm by 2 pi cos omega mt. Then the maximum departure of the frequency from the unmodulated carrier frequency fc is given by k vm by 2 pi as the maximum value of cos omega mt is equals to 1. So we can write the deviation, maximum deviation is k vm by 2 pi. So this delta f is proportional to the amplitude of the modulating signal, but it is independent of the modulating signal's frequency. The ratio delta f to the modulating signal frequency is called the frequency modulation index, that is kf vm by omega m. Then this term is changed as Vc frequency modulated is written as Vc cos omega c into t plus mf sine omega m t. In the amplitude modulation, the amplitude was changed like the envelope of modulating signal. It was the change of amplitude due to the envelope of modulating signal, and in this case the frequency is changed, and sometimes the frequency is increased and sometimes it is decreased. Several type of frequencies will be found in the modulated carrier. In the amplitude modulated carrier, there are only two sidebands, but in the frequency modulated carrier, there are several sidebands. It may be Fc plus minus Fm, it may be Fc plus minus 2 Fm, etc., up to Fc plus minus n Fm. Actually, it is proportional to the Bessel's polynomial Jn of Mf. Where Jn is the Bessel's function of first kind of order n. If Fm is the modulating frequency, the bandwidth will be 2n Fm. If we break the formula, then we get the several frequency modulated terms as from the Jacobi series of Bessel's polynomial. Since we know cos of mf sine omega mt is equal to j0 mf plus 2 summation n equals to 1 to infinity j2n of mf cos 2n omega mt, and sine of mf sine omega mt equals to 2 summation j2n plus 1 of mf sine 2n plus 1 omega mt, n equals to 0 to infinity.